Okay, our goal here is to find the value of the question mark symbol right here in the equation below. So our answer should be 1 over 2 to the third, which is 1 over 8. So how can we get that? Well, 2 to the fourth and 4 squared. What's going to happen right there? Well, one interesting and phenomenal thing I think is beautiful is that 2 to the fourth is the same thing as 4 squared. And there are different ways to look at this, but 4 squared is 4 times 4. And I know that 2 to the fourth is 4 4s multiplied. 2 times 2 times 2 times 2. If I just regroup these 4 2's, I can see that we have 2 times 2 or 4 times another 4 here, right? You can see this equivalence without calculating. What does that mean for us? It means it's awesome. These cancel out, right? They're equivalent. So now, right, we have 2 to the 500th over 2 times 4 to some power, and we should get 1 over 2 to the third. So I notice that I can take 2 to the 500th, right, which is 500 2's being multiplied in a row. This crazy amount of 2's, right? 2 times 2 times 2 times over and over and over again, altogether 500 times, right? There are 500 2's. Well, here we have 1 2, and we're dividing by it. So take those 500 2's, right? I'll write them over here like this, and we're dividing 1 2 out. So that means this 2, when you divide it, it will cancel with one of the many 500 2's we have here. So I'll cancel this one out. That means that there are 499 left over. So when these two 2's cancel out, we have how many 2's left over? Well, there are 500 to begin with, one canceled out. Now we have 2 to the 499th power. So if you think about this strategically, what we have is 2 to the 499th, right? Over 4 to the something, and we should get 1 over 2 to the third. Well, you know, if you think about 2 to the third and what's going on right here, that means you get 1 over 2 times 2 times 2. In other words, what you should set up for a power of 4 is a power so that there are basically 3 2's left over, right, when you divide this thing out. How do we do that? Well, here, right, we can look at 499 2's lined up. That means we have at least how many pairs. We want to figure that out, right? So if I look at this numerator one more time, 499, how many pairs is this made up of, right? Well, all these 2's lined up, right? We have 499 of them. If we think of pairs, that's every 2 2's. In other words, we can divide this thing by 2 to find out how many pairs we have. 499 is not an even number, but it's really close to 500. There's almost 250 pairs here. So this is almost the same thing as 4 to the 250, but there's one power, right, less. So I think of what if we had 498 2's in a row? That would be like having 249 pairs of 4's. So it'd be 4 to the 249th with 1 2 left over, right? Because there are 499 2's. So again, what just happened there was I said, well, 4 to the 249th, right, is like having 498 2's in a row. Just this thing doubled here. And we actually have 499 2's, so we still have 1 2 in the end. So wow, what does this tell us? Well, looking back at this problem, it allows us to kind of rewrite things a little bit. We know that the 4 in the denominator right here is going to be raised to some power, right? But if it were to be equal, if it were to cancel out exactly, you would write 4 to the 249th times 2. But that's not what we want. We don't want this thing to cancel exactly, right? This would divide out to 1. We want it to be 1 over 8. So we need a couple of more 2's in our denominator over here, right? So how many more 2's do we need? Well, if this equals 1, these two things are equivalent, we need 3 more 2's in the denominator. So we need to take this thing and multiply it by 2 to the third. Right? That would give us the extra 3's we need when these things cancel out, because this part right here is just 1. It divides to 1, and that 2 to the third is left over. And we're almost done now. What this allows us to basically do, if we think about this, is answer the question. Finally answer the question, right? Here, we want to know, if we go back, 4 to what power make all this stuff cancel out? So in other words, can we express all of this stuff here as a power of 4? Absolutely, right? How? Well, 2 to the 499th power is still in that numerator. We're just evaluating this and looking at it. In the denominator, we have 4 to the 249th. What would this be? 2 times 2 to the 3rd, that equals 2 to the 4th. So it's times 2 to the 4th. And we said earlier that equals 4 squared, right? So we can think of this as 2 over 499 over 4 to the 249th times 4 squared. And lastly, finally, we finish. This is 2 to the 499th power over 4 to the what? Well, we can add these two exponents. It's 4 to the 251st power. And that's your answer. And if you look at these two, right, if you think about what's happening, you can see that this would cancel out. Let's just look at that one last time, because this problem is really tough. This is 2 to the 499th. 4 to the 251st power, if we think about what that is, it's 251 4s in a row. Each 4 has 2 2s, so this is really the same thing as 2 to the 502nd power. And if we look at this and we subtract these two, 499, right, they have the same base, we subtract the exponents, minus 502 is negative 3. It equals 2 to the negative 3, which is 1 over 2 to the 3rd, right, and we get our answer. So I don't know if my strategy, I hope I didn't confuse you. I was just kind of playing with the numbers to find out what it would equal. There are certainly more precise ways and quicker ways to get the answer. I just want to show you the intuitive way, at least the way I think about it, to solve this problem. I hope it helped. Thanks.